Hello and welcome everyone. In this video, we will see an example of 2D pore pressure diffusion, which is considered a major triggering mechanism of injection-induced seismicity. The example results that we will try to reproduce in this video are from this 2011 abstract by Professor David Eaton from the University of Calgary. Before we do it, I would like to mention another important reference, which is a book on fluid-induced seismicity by Sergei Shapiro, in case you are interested in learning more about the topic. For a homogeneous and isotropic material, we can use the diffusion equation to describe the pore fluid pressure diffusion process. Here P is the pressure perturbation, and it is generally taken as the deviation from the hydrostatic pressure conditions. And D is the diffusivity tensor. So following Dr. Eaton's 2011 abstract, we built our discretized model where we have an injection layer surrounded by the background medium. The injection point is placed at the center of the model. The diffusivity tensor values are taken the same as in Model 4 in Dr. Eaton's abstract. The grid spacing delta x is chosen to be 1 meter and delta t is chosen to be 1 second, satisfying the stability criterion. Using an explicit finite difference scheme, we solve the diffusion equation and obtain this solution at time t equals to 2900 seconds. Now, if we compare it with figure 2 in Dr. Eaton's abstract, we get the same eye-like shape in 2 dimensions, which suggests that we have successfully reproduced the results. The details on the finite difference stencil used in this video include forward difference for time and second order difference for space derivatives. Rest of the implementation details I leave as an exercise for you. Please watch other relevant videos on my channel and give it a try. I'll also place the link to some of the relevant videos in the description of this video. I hope you like this video. Please subscribe to my channel and thanks for watching.